This video will serve as an introduction to vectors, which are a type of quantity that we'll use quite commonly in physics. A vector is a quantity that has both magnitude and direction, which means that it has a number associated with it, quite often with units, as well as a direction. Sometimes that direction is left, right, up, or down, or sometimes it's north, south, east, or west, or sometimes it's at an angle, as we'll see in a little bit. Vectors are represented by arrows, which is convenient because arrows have a length and they also have a distinct direction. When we're using variables for something that is a vector quantity, we need to include the vector symbol with them. So let's think of some vector quantities that we've had already. The vector quantities we've already seen in physics include displacement, velocity, acceleration, and force. So now, when we're using these variables for our quantities, if we care about the direction of the quantity, we'll use this little vector symbol on top of the variable representing that quantity. One important skill that you need to have related to vectors is finding a vector's components. A component gives the magnitude and direction of a vector according to two perpendicular axes. The most common components that we'll find will be x and y components of vectors. Let's look at an example of exactly what that means. So here's our vector here. And here's an x and y axis drawn at the tail end or base of our vector. This blue vector that you've seen here that is parallel to and along the x-axis, that shows the component of my vector. You'll see that components are vectors themselves. They have a distinct direction as well. And here's my y component of my vector. I have a slightly different vector, this new one on the right-hand side. You'll see that my components look slightly different. My x component is pointed left now rather than pointed right, and my y component is pointed downward rather than pointed upward, as in my first example. And that comes from the fact that if I look at this purple vector that's on the right-hand side of my screen, I see that it points down and left rather than pointing up and to the right like my first. Let's look at exactly how to find numeric values for vector components. Our first step is going to be to draw an xy axis at the tail end of our vector, like so. Then we're going to draw those x and y components. Now it's really important that when you draw components, you draw them as vectors themselves, and that means that they have arrows as well. So here's my x component, starting from the origin of my xy axis and going to the right, since this vector goes up and to the right. And here's my y component, starting at the origin of the xy axis and pointed upward. Quite often, we'll be given a magnitude and direction of our overall vector. So let's say that this vector has a magnitude of 10 newtons, and let's say that this was an angle of 30 degrees here. Now, it says that we could use SOHCAHTOA to find the magnitude of those components. To do that, we need a right triangle. So we'll move that y component over to the right-hand side here to make a right triangle. And we know it's a right triangle because x and y are perpendicular to each other. Now we can use trig functions, sine, cosine, and tangent, to be able to find those two components, this being my x component and this being my y component. More specifically, the sine of our angle, the sine of 30 degrees, we know that sine is opposite over hypotenuse. So that would give me the y component divided by the hypotenuse of 10 newtons. Similarly, the cosine of 30 degrees, which is adjacent over hypotenuse, would give me my x component over 10 newtons. I can use my calculator to find that. And it's really important that you make sure that your calculator is in degree mode, since our angles in physics will always be measured in degrees. Now, sometimes, rather than finding x and y components, it'll be more convenient to find a component of a vector that is parallel to and perpendicular to an incline. So here's an example. I have a block sitting on my incline or ramp here. And let's say that I have a gravitational force acting on my block, and I want to find the components of the gravitational force that are parallel to and perpendicular to this incline. Our first step before was to draw an XY axis, but this time I'm not using X and Y components. So my axis is actually going to be parallel to and perpendicular to my incline, like you see here. Then I'll draw my two components. Here's my first component. Notice that it goes along the incline. It's parallel to the incline. And then my next component is going to be perpendicular to the incline. I've already drawn it in its location to make a triangle out of those components, rather than drawing it along this axis right here. Now, let's say that in this problem, we were told that this ramp was at an angle of 20 degrees, and we were told that this force is a gravitational force with a magnitude of 30 newtons. Now, we know that this is 30 newtons here, and we know that these two components are perpendicular to each other. So that 30 newtons, not 30 degrees, 30 newtons is my hypotenuse of my triangle. But I need to figure out where my angle is located. So if I take a look here, I can see that there is a triangle created with my force, which goes straight down, along with this angle, and that goes up right here. And because my force is straight down and the bottom of my ramp is horizontal, this is a right angle, which means that this angle right up here would be 90 minus 20 degrees, or 70 degrees. That comes from the fact that the angles within a triangle, and the triangle that I'm looking at looks like this, must add up to 180. So I have 90 degrees here, I have 20 degrees here, and I have 70 degrees here. I could then focus on my triangle made with my components to find the component that is parallel to the incline and perpendicular to the incline. In this case, if I was trying to find this parallel component, I would use the cosine function, because the cosine of 70 degrees would give me that parallel. I'm just going to use two lines to represent parallel. Let's make sure those lines are slanted, because if I make them straight, it may look like I'm writing an 11. So the parallel component divided by the hypotenuse, or 30 newtons. And then I could use the sine of 70 degrees to give me the component that is perpendicular to my ramp. Of course, do lots of practice with this in class.